Okay, today's problem is called the pancake sorting. So, if you look at the description of the problem, it is pretty misleading. So, you have this kind of this array which is given, and then they have given down a set of approaches which is used to solve this array. So, what we have to do is that we have to use a reverse function to kind of do this pancake sorting, and so what we have to do, let me explain a bit. So, if we have an array called uh, maybe 3 2 1 4, then what we can do, we are only allowed to do a pancake reverse. That means we can only take an index up till I. So maybe this is the ith index, right? This is the ith index, and we have to basically reverse from the beginning of the array to till that index. So we can reverse from here till here, and we have to do a sequence of such steps to get the get the array sorted. So in this case, we only have to do one reversal, and this results in the array becoming 1 2 3 4, which basically the array becomes sorted. So there can be multiple approaches for doing this. We For each approach we have to figure out or we have to give an array which gives the sequence of this I choices that we take. Here is I only will be like the third index, right? So for a 0 index it will be 2, and then for a 1 index it will be 3. So in this case you have to return 1 index value. So I will be 3 here, so that will be the answer, because that's the only reversal that we did, and that itself sorted the entire array. So we can there might be other ways also to do it. So any of the set of reversals which gives the correct answer is acceptable, right? So this is the description of problem, but this is exactly where the problem becomes confusing, because especially the explanations are even more confusing, because it gives you a very random approach to solve this array, right? And looking at this explanation, you absolutely get no clue of how to kind of take any random array and figure out an algorithm to perform a sequence of flips such that the array becomes sorted, or to be more precise, to a sequence of pancake flips, in which again, as I explained, we take an I index and then flip reverse the sub array starting from the start of the array to that particular index, right? And we do a set of such operations so that finally the array becomes sorted. So yeah, looking at the reading the problem, it is quite confusing. Also they have given a criteria that the number of flips should be less than 10 times the array length. Okay, so that's another criteria. So yeah, reading this is it is very confusing, but actually if you look at it, if you know the solution, the problem is very easy. So the main hint of solving the problem is basically it comes from selection sort. So what we do is selection sort is we basically identify the so suppose if you are trying to basically do an yeah, trying to convert the array into an increasing sequence, what we will do is that we will eventually find the maximum value of the array and try to shift it to the end, and then that means the max value of the array is now at the end, right? And then we try we try to find the second maximum value and shift it to the second last position, and so on and so forth. And we finally, after n minus one such shifts, we would get the array sorted, right? So that is pretty straightforward selection sort. So that is where our logic lies. Okay. So basically what I do now is I'll go through a dry run, and then and from there it will be evident that how are we exactly performing this sequence sort with this uh, coupled with this pancake flipping. Okay, so that will be very clear when we go through the go through the dry run now, and then after that I'll just run you through the code quickly, which is just the implementation of the same principle. So okay, now let's go to the dry run. So I've taken the same array, and we are trying to do a selection sort kind of logic here. So what we'll do is that we identify the max element, and we'll flip starting from the start index to here. Okay, we'll flip. So that will result in the array becoming this, right? And then, but we want this to be at the end, right? And to be at the end of the array, right? So we do a flip of the entire array, and then it comes here. So the basically now after this, the maximum element is coming to the end of the array, which is what we want, right? So that is the basic logic that we'll do in every step. So after this step, after coming here, our maximum element is already at the end, and now obviously this part of the array is sorted, right? So this part of the array is already sorted. Uh, so which is here. So elements of this part of the array is already in place. So we don't need to worry about this. So now we have to find the maximum element in this part, right? So maximum element in this part is obviously 3, right? And then what we do is that we basically would flip the here, right? And flip here, and then it will result here, and then we'll do a flip of the entire this part after this, right, which will bring us till here. Then after that, these two are sorted, right? You can easily see the like the logic, given logic behind this, and all the while we are doing this, we're also updating the result array after doing every flip. So in the first step, as you know that we have flipped the third kind of index, right? So we add 3 here. If here k equal to 2 for a 0 index array, but we have for the result we have to give 1 index answer, so we do a k plus 1, and that's why 3 is added here, right? uh, and then for the next step, obviously we flip the entire array, and then that's why 4 is returned to the end of the result, because we have flipped from starting from the beginning to the 4 index, right? And then last index in the program, we do it in a 0 index way, because that's how programs are in C++. And then you have to add +1 to this. This will be clear when we go through the code. Okay, and then basically we do the same thing, right? We go through the same steps, and then here are the steps, and finally we reach the right answer. And then after we have managed to kind of bring the largest n minus 1 elements in sequence, then for the remaining element we don't have to worry, because that would be automatically sorted. So then our algorithm finishes, right? So basically our last index would move from here till here to the iteration. So basically from n minus 1 index to 1 index, and this 0 index we don't do anything, because that is automatically sorted, right? So that's the logic. So I think everything is clear now. Let us move to the implementation of the problem. So here is the same thing, like we basically move the last index from the array size -1 to 1, because after that the first index would be automatically sorted, and then we choose a generic max value and then k, right? And then then we find here, basically we are trying to find the max value and try to find the index corresponding to the max value. First we are flipping up to the max value, right, and then pushing back the result, and then we are flipping the full array till the last index, right, for the correct iteration. So this is we are continuing every time, and then obviously pushing back to the result. We are continuing this for all the last index, for all the loops of the last index, till it reaches obviously 1, and then we are done, right? We are sorted, and when basically we return the result, because that is the demand of the problem. We don't sort if k not equal to the last index, because that means the maximum value is already at the last index, which is anyway our requirement for the particular iteration of array. So why to do all this reversal with, if anyway that thing is if the last element, the max element for that particular iteration of last index is already at its correct place, we don't need to do all these reversals. So yeah, we only do these reversals when k is not the last index, right? Yeah, so that's the entire logic of the problem. This passes all test cases. Okay, so hopefully you understood this video. This is very simple enough, slightly confusing if you look at the description, but solving it is simple enough. Okay, I'll see you in the next video. Thank you. Bye.